Okay, so let us look at this code. I have got the image to be resized to a size of 1.25. Okay, and I'm just getting it executed. Control T. I'm doing it to uncomment the code. Okay, so here we are just getting the thing executed. You get the output. Okay. With the output, I'll just explain you. Okay, so this is the original image, which is indicated here in the form of I. I is the original image. This is a TIFF file, TIFF file, built in, like a sample image available in MATLAB itself. I'm just resizing the image to a size of 1.25. So I'm just increasing the size of the image. Okay, so this is what is given here. I hope you're clear with subplot, everything. So the whole figure window is just divided into 4 divisions here. 2, 2. This 2, 2 indicates actually the whole figure window is divided into 2 rows and 2 columns. I have it here, 2 rows, first row, second row, and 2 columns, and this indicates the index. So 2, 2, 1 means this is the figure, and 2, 2, 2 means this is 1, 2, 2, 3, 2, 2, 4. So in 2, 2, 1, I have the original image. In this case, I have got the resized image, which is 1.25. So this image is just zoomed up to a size of 1.25. So you could check with the value which is available with J. Let us go with the workspace. Now you could see that it is original size of I is 280 cross 272, whereas now J is of size 350 cross 340. So the number of pixels which originally I was having, and now the pixels with J, how it is having, it's just getting increased. Okay, so the number of pixels available in the image J and I, if you compare, image J has this variable J, which contains the original image being resized, is having more number of pixels. That means I have just done interpolation. Okay, I've done interpolation. So by default, you can do any type of interpolation. What do you mean by interpolation is you just start some values. Okay, it can be zeros or it can be some nearest neighbors. You basically know what is interpolation, as you people are of at least 3rd year. So you'll have finished up signal processing in your 5th semester, or if it's some other people just learn what is interpolation is, just increase the size of the number of samples. Okay? Sampling rate is just increased. Fine. Now again here, this is again the image I, which is resized again to a size of 100, 150. So let us check with the size of K. Okay, let's go to the workspace. Workspace monitoring the workspace is very important. Am I there in the session? Excuse me. I think by mistake someone got unmuted, or if it's a doubt, I'm ready to get it clarified. Excuse me. Yes.
No, ma'am. Yeah. Somebody has unmuted. I removed them from the meeting.
Okay, okay, sir. Okay. So K, let us take with the size here. Though the original size of I is 280 cross 272, when you check with the size of K, it is now resized to the size which we want. Okay, it is now downsized to a size of 100 cross 150. How do you mention it as 100 cross 150? It is just done here. Okay, so the original image I is now resized to the size which we want actually. Okay, the size which we want is mentioned to be of 100 rows and 150 number of columns. Okay, so this is how it is done. So you could see that it is now resized to 100 number of rows and 150 number of columns. Okay, so in this case, originally it was 380 cross 720 or something. So that's actually getting, I'm not remembering the original value, 280 cross 272. Okay, now it is just resized to a size of 100 cross 150. Okay, then the last image is actually interpolated with bilinear interpolation. There are different type of interpolation techniques. They have done interpolation with a factor of 1.5, and they have done interpolated with 1.5 with bilinear interpolation. As I said, you have a cubic interpolation, like you have nearest neighbor interpolation. One type of interpolation technique is bilinear. Okay, why do you need such kind of resizing is depending on the type of application which you use. Accordingly, you may want the image to be increased to a size bigger one. Like if you are processing on with images more number of images acquired from different sensing devices, and all of them will be of different sizes. Okay, so one may be of size 100 cross 150, the other may be of size 200 cross 300. So if you want to uniformly resize all of them together to be of one size before you go on with any such kind of processing, this image resizing plays a vital role in such kind of application. Okay, so I could say that lim resize is an important function necessary for such kind of pre-processing technique. Okay, so let's finish up with this image resizing. I've done with it. Okay. Now let us go with which type of adjustment.